Welcome back, day 16. Dragon checksum. You're done scanning this part of the network, but you've left traces of your presence. You need to override some disks with random looking data to cover your tracks and update the local security system with a new checksum for those disks. For the data to not be suspicious, it needs to have a certain priorities. Purely random data will be detected as tampering. To generate appropriate random data, you need to use a modified dragon curve. Start with an appropriate initial state, your puzzle input then, so long as you don't have enough data yet to fill the disk, repeat the following steps. Call the data you have A. Make a copy of A. Call it B. Reverse the order of the characters in B. In B, replace all instances of 0 with 1 and all 1 with 0. The resulting data is A, then a single 0, then B. So 1 becomes 100. 0, 0, 1, and then, okay, so we just flip. So you reverse and then flip until you have enough data. Once the data has been generated, you also need to create a checksum of that data. Calculate the checksum only if the data that fits on the disk. Only for data that fits on the disk, even if you generate more data. The checksum for some given data is created by considering each non-overlapping pair of characters in the input data. If the two characters match 0, 0 or 1, 1, the next checksum character is a 1. If the characters do not match, the next checksum character is a 0. This should produce a new string which is exactly half as long. If the length of the checksum is even, repeat the process until you end up with a checksum with an odd length. For example, okay, we want to fill a disk with 12, and then we finally generate a string, which is this one. We look at the pairs, and do same, different, same, and then we have this. So we have 6, which is even, so we do again, and then we have 3, which is odd. So we stop, and then that's the checksum. Combining all these steps together, we do this. Okay, let's do that example. The first disk you have to fill is 272. Well, in the example, we need fill a length of 20 with this. Okay, so let's walk through it. First, we just apply it with 272, and then we apply it with 3, 5, 6, 5, 1, 5, 8, 4 against the puzzle input. And what we do is, while the length is smaller than we need the length to be, we take the input, add a 0, reverse this input and flip it and append it. So reversing is just reversing the characters in the string, getting a new string, flipping. If it's 0, it's 1, and if it's 1, it's 0. Getting a new string, and then we just add that until the length is big. Length may be longer than length, so we only take length characters, and then that's our input. Then we input that into the second while loop, which checks if the length is even amount of characters. Then we collapse, update it, and check again until we have an uneven amount. And collapsing, what it does, it takes 2. If they are takes 2 characters from the string, if they're equal, then we add a 1 to a new string. Otherwise, we add a 0. We do that for each 2 characters. There's 2 consecutive characters in the string. That's what our output string is. And then once we have an odd one, an odd length string, we can print it, and that's the checksum. That's it.